Now 5 is a trig function. And we did one trig function already, and we let u be the argument, but there was only one trig function involved with that. Think of this as the integral of sine 3x, the whole quantity squared, and then times cosine 3x dx. So do we have something that's in parentheses being raised to a power? Yes. So what are we going to let u be? Yeah, sine 3x. If you just let u be 3x, then you would still be trying to integrate sine squared u times cosine u. And we don't know a function whose derivative is sine squared cosine. And that's why sometimes it takes trial and error too. If you let u be the wrong thing, you're going to know it pretty quickly because you won't be able to integrate it even after you've substituted your u's. Right, and if you do it this way, you immediately know it's the right way because it becomes really easy. What's the derivative of sine 3x? Times 3. So 3 cosine 3x dx. Which conveniently enough, I've got the cosine 3x dx, so all I need is the 3. And if I stick a 3 inside, I have to stick a 1/3 outside. Bless you. All right, so when I make my substitutions, what am I left with? Riley? Okay, hold on. Let me. U squared times du. Riley, what's your question? Okay, when you take the derivative of sine 3x, the derivative is cosine 3x times the derivative of 3x. All right, everybody okay with the u substitution? All right, so what's the integral of u squared? Yep, 1/3 u cubed plus, see, so 1/9 u is sine 3x cubed plus c. Okay. When you've picked the right thing to let u be, you're going to know it. All right, what's different about number 6? It's a definite integral. Good, because it's got your limits of integration. All right, we're going to work it the exact same way. So what do you think you're going to let u be? Good. X squared plus 1. Du? 2x dx, is that going to fit? Or can I make it fit? Absolutely. All right, so we have 1/2 integral. What do we get when we make our u substitutions? U cubed du. Okay? All right, now I need to talk about these limits of integration for just a second. The original problem was in terms of x's. So those limits of integration are in terms of x. But now I've changed, and by the limits of integration, I'm talking about the 0 and the, is it 1? Okay, I'm talking about the 0 and the 1. When I switch my variable to a u, I need to switch my limits of integration to u, because it's going to make it easier on us at the very end if I do that. So this 0, that's when x is 0. When x is 0, what does u equal? 1. Yeah, I'm just going back up to my u equals x squared plus 1 equation. When x is 0, u is 1. When x is 1, what does u equal? 2. So now my limits of integration are now in terms of u. And just hold that thought for just a second, and I'll show you why that's important, or why it's a shortcut in just a second. Yeah, the 0 and the 1, your limits of integration, those are in terms of x's, because the problem is all in terms of x's. So when we substitute the x's with u's, I need to change my limits of integration so that those are in terms of u. And this bottom limit of integration right here is a 0. Well, that's an x value. So I just go over here to my u equals x squared plus 1 and plug in a 0 for x. And I get that u is 1. And when x is 1, u is 2. Absolutely. For all of, anytime you have an indefinite integral, you're going to plug your limits of integration into your u equals and be done with it. Okay, so when we actually integrate, we get 1/2, and then the integral of u cubed is 1/4 u to the 4th. Do I need the plus c? No, I do not need the plus c. And then I draw my little vertical line and say I'm going to integrate that from 1 to 2. Because the next step is to plug in a 2 minus plug in a 1, and the c's would cancel. If you want to put the plus c, that's perfectly okay. All right, I'm going to simplify this into 1/8 u to the 4th, 1/8 u to the 4th from 1 to 2. Now, because the 1 and the 2 are in terms of u, I can go ahead and plug in the 2 minus plug in the 1 into the u, instead of having to go back and substitute x squared plus 1 back in for u. And then if I were to do that, which limits of integration would I use? The 0 and the 1. So I personally think it's a heck of a lot easier to change your limits of integration to u so that when you get to this step, you can go ahead and plug in those numbers and not substitute back in the x squared plus 1. Plus, I think it's a heck of a lot easier to plug something into u to the 4th than into x squared plus 1 to the 4th power. That's my personal opinion. Also, when I'm plugging stuff in, so I'm going to have 1/8 times 2 to the 4th is 16 minus 1/8 times 1. So 16 over 8 is 2 minus 1/8. You're welcome to leave it like that, or it's 15/8. Yes, because I changed, okay, the original integral started with 0 to 1 in terms of x's. Because I changed that to 1 to 2, which was in terms of u's, then I can use that with my u right here, as opposed to if I didn't change these limits of integration, I would have to plug the x squared plus 1 back in, and then I could go back to using 0 to 1. But it just makes it a little bit more simpler, in my opinion. Start number 7 off on your own. All right, so u is 2x minus 1, du is 2 dx. So I stuck my 2 in and my 1/2 out. But how do I deal with this x? Okay, good, solve for it. So x is going to equal u minus 1, u plus 1, thank you, divided by 2. All right, and then personally, the first step I would do is rewrite this as 1/2 times u plus 1, and then instead of dividing by u to the negative 1/2, instead of dividing by u to the 1/2, I could multiply by u to the negative 1/2 du. Do y'all like pulling out that 1/2 that's inside? Okay. Oh, I meant to do that too in this first step. So I do need to rewrite my limits of integration. If x is 1, u is also 1. and that's fine. If x is 5, u is 9. Thank you. Forgot about that. Okay, it's because when I stuck the 2 in, it came from outer space, and I stuck that 2 in to the problem. And therefore, I have to compensate by putting the 1/2 outside. But when I pull this 1/2 out in front, it's part of a problem inside the integral, and it's still part of the problem outside the integral. I'm just moving it to a different place. So that really should be 1/4 outside. And then if I distribute the u to the negative 1/2, I get u to the 1/2 plus u to the negative 1/2 du. Okay, now I'm going to actually integrate. And I get 2/3 u to the 3/2 plus 2 u to the 1/2. From 1 to 9. Would you prefer to distribute the 1/4 through the parentheses first, or plug in 9 minus 1 and then distribute 1/4 through all of that? Same time? Okay, we can do that. All right, so 1/6 times 9 to the 3/2 plus 1/2 times 9 to the 1/2 minus 1/6 times 1 plus 1/2. All right, what is 9 to the 3/2 power? 27. So we've got 27 over 6 plus 3/2 minus 1/6 minus 1/2. 26/6 plus 1, or 13/3 plus 1, same thing. All right, that right there is pretty much as hard as it's going to get. 26/3 plus 1, which for those of you with algebraic guilt, that would be, or 26/6 plus 1, that'd be 13/3 plus 1, or 16/3. We will do the last problems tomorrow. They're pretty short, but I'm going to save that till tomorrow.